Okay, everyone, welcome to the last video for our week 5 section. So in this section, we're kind of just going to look at what we've been doing with solving equations, except the twist is that we can kind of apply it to real world applications. So what do I mean by that? Um, Basically, the only change is that the examples will be given in Word format. And then from that point, from the Word format, you have to kind of extract what is being said mathematically, put it in terms of an equation, and then solve the given equation. So we can apply linear equations to real world applications. I will say on page 158 of our textbook, you will see a chart enlisted in section 3.5. And it's basically a chart just of like certain words that are used quite often mathematically. So for example, total, sum, stuff like that, that can kind of help you just to be able to pinpoint what certain words mean mathematically in English. Okay. So let's look at our example. Best thing to do in these cases is just to go straight into an example. A number minus 6 is negative 22. So notice we're not given directly the equation. We first have to format the equation. Once we format the equation, that's when the math comes in and we can go ahead and solve. Well, we want to find that number. So first things first, we have to go ahead and define what this number is. Remember, this number is a changing value. So that implies it's some variable right now. We don't know what it is yet. We have to solve for it. So we're going to say let x, oh, there it is, x represent the number, or a number, we'll say. So and this is just for, because again, you don't have to choose x. It's just some variable. So someone could have y, someone could have x, z, doesn't matter what it is. But this is just so whoever is looking over your work, they can see, oh, that is what they're using to represent this unknown number right now. So some variable. Well, this is where now we have to dissect what the English is telling us mathematically. So we'll go word by word. A number, so there's our x, minus. Well, what does minus imply? We're taking away. So x minus 6. And then one word in mathematics that means something. So just like, again, total, sum, difference, product, those all mean something concrete in mathematics. So does the word is. So it might be silly, but the word is a very important word. Mathematically, is implies equal to. So here we see a number, here's our number, minus 6, and then is. So that's where our equal sign will come in. So x minus 6 is what? Well, negative 22. And then from this point on, we can go ahead and solve. So notice we want to isolate for x. We want x all by itself on one side, but this negative 6 is in the way. Well, remember what we have to do? We have to do the opposite of what is being done, the inverse operation. So that means we're going to add 6 to both sides so that negative 6 can cancel out and appear on the right side and leave the x alone, completely isolated. So then we have x is equal to, well, what is negative 22 plus 6? In this case, we have more negatives than positives, so we're going to have a definite negative answer. And then from that point, when we subtract the larger absolute value from the smaller absolute value, we can see we then have 16. Oh. But remember, there's a check step. So here, if we look at our check step, you can see here that we have our equation, but again, now we're saying that x is equal to negative 16. So instead of x minus 6, we have negative 16 minus 6. And if you can see on the left and the right side, we have the same number. So we know for sure this is a true statement. So therefore, this is our final answer. Okay, next example. This one can be a little tricky with wording. That's why I wanted to go over it. So be careful. Sometimes it's not as straightforward. The language is not as straightforward as in our first example. So let's read over it once. So 4 subtracted from 8 times a number. Yet again, notice we're running into this number. So again, I'm just going to say for defining purposes, let x represent a number. And of course, you can word this in your own way. It's just so someone who's looking over it. So again, me, if I'm grading your work, I can see what you're doing here. So it's something to start off on. Okay. So 4 subtracted from 8 times a number is 36. So let's see what we have here. So far, we have 8 times a number. Let's go ahead and look at that first. So what is 8 times a number? Well, times implies which operation? Multiplication. So we know that 8 times some number. So 8 times x. And we know that 8 times a number, 4 is subtracted from it. So this is where I want to really add emphasis. Some people would read this as to be 4 minus 8x. Be careful. You have to be careful to decipher what the English is saying. This is incorrect because we're saying, well, whatever is 8 times this number, from that, we are subtracting 4. So it's not the other way around. So you really have to make sure you're being careful because this is not equal to this. These are two different things. So we have to be careful and really read down who is being subtracted from what or what operation is being given and be cautious with that. So again, it's 8 times a number. So here that we have that. And from that, we're subtracting 4. So from 8 times a number. And then there's the word is again. So there's our equal sign is 36. And then from this point, we can solve. So notice we're going to add 4 to both sides to go ahead and start isolating for our x. Remember, at the end of the day, we want x all by itself. So we got to go layer by layer on isolating that x. Here we can see we have 8x minus 4 plus 4. This goes to 0. And we're left with 36 plus 4 on the right-hand side, which is 40. And now we're almost done. But remember, I don't want 8x, I want just x. So that 8 and x are glued together with multiplication, and I want to undo that gluing. Well, what is the inverse operation of multiplication? Division. So if I multiplied by 8, I want to divide by 8. Because again, notice 8 divided by 8, well, that's just 1. So then I would have 1 times x, which is just x, which is what I want. So then I have x is equal to, and now I just have the right side to figure out 40 divided by 8 is 5. And of course, before we guarantee, let's look at our check solution. And remember, all we're doing is wherever there's an x, now I'm saying, well, that's the same thing as 5. So here we have 8 times 5 minus 4. And notice once we go ahead and simplify, we get 36 equal to 36. Beautiful. The left and the right side are the same number. So that brain's going fast again. That means that we know that this is our solution. And this will conclude our week 5. So this will also be the last material on our given midterm. And yeah, questions, comments, concerns, please shoot me an email.